Imagine this. You wake up on a perfectly normal morning. Sunlight slips through the curtains. Everything looks familiar. But then you pick up your phone, and nothing works. No 4G, no Wi-Fi, no GPS, no satellite signal, no connection to anything. Every electronic device around you feels dead, silent, as if the entire world just stopped breathing. You turn on the TV, no signal. You step outside. Cars are stalled across the road like a frozen simulation. Airplanes lose navigation. Banks go offline. Global communication collapses in less than an hour. And if this moment ever arrives, the cause won't be hackers. It won't be war. It won't even be human. The cause will be the cosmos. A silent blow from above, sudden, unstoppable, and indifferent. Today, you are about to hear 7 cosmic disasters that could hit Earth in your lifetime. Some would plunge society into chaos for weeks. Others could force civilization to start over from zero. None of this is fiction. These are real scientific scenarios backed by NASA, ESA, and decades of astrophysical research. And the most unsettling part? Not a single one of these threats has a probability of 0. Before we dive in, remember 3 truths that completely reframe how fragile our world really is. Truth 1. The universe does not care about us. It does not hate us. It does not protect us. It simply acts. Truth 2. Our civilization is far more fragile than we think. A burst of radiation, a fragment of rock, a failed orbit, any of these can flip the switch on modern life. And truth 3. Several disasters on this list have already happened in Earth's past, and history has a strange habit of repeating itself. By the time you finish this video, you will understand which threats are almost certain to happen again, and which ones could strike within your own lifetime. This is video 3 in the Astro 365 Cosmic Series. If you believe the best way to protect humanity is to understand the universe, hit subscribe, because what you're about to hear may be more important than anything you learned in school. Now let's begin with the most immediate threat, one that could reset the modern world in a single afternoon: the solar superstorm. Imagine the sun not as a calm ball of fire, but as a raging ocean of plasma, twisting, boiling, and erupting every second. Streams of charged particles, solar wind, flow past Earth constantly, and most days our magnetic field deflects it like a shield. But sometimes the sun explodes. A coronal mass ejection, CME, blasts billions of tons of plasma into space, a wave of magnetized death moving faster than a bullet. If that wave hits Earth head-on, our magnetic field shudders violently. Electric currents surge through power grids, through transmission lines, through every kilometer of metal we've built. Transformers overload, substations ignite, satellites flicker, glitch, and die. This is not theoretical. In 1869, it happened, the Carrington event. Back then, humanity had no satellites, no GPS, no global internet, yet even primitive telegraph lines caught fire. Operators felt electric shocks. Some telegraph machines continued to run after being unplugged. Now imagine Carrington happening today. Entire continents losing power, flights grounded, navigation gone, banking systems collapsing, the global economy stunned into silence. And here's the part that should make you uneasy. Statistical models show a 10 to 20% chance of another Carrington-level superstorm in the next century. That means absolutely within the time frame of your lifetime. NASA monitors the sun 24/7. We can issue warnings hours before the impact, but warnings don't stop physics. They only let operators shut down parts of the grid and hope the damage isn't catastrophic. And the most chilling truth is this: if a massive CME launches directly toward Earth, we will know. We will watch it cross space, hour by hour. We will see the data spike. We will understand exactly what is coming. But we will not be able to stop it. One moment, the world is normal. The next, The lights go out. The sky erupts with auroras so bright they cast shadows on the ground. Green, red, violet curtains dancing above cities in chaos. Beautiful, mesmerizing, and a sign that our shield is breaking. If the sun ever decides to strike at full power, modern civilization will not be ready. Short hook version for 18 to 20s. The sun could erase the entire global internet in 30 minutes. Not with weapons, not with war, but with a single explosion of plasma from 150 million kilometers away. If another Carrington event hits Earth, we will watch civilization fall back to the 1800s before we even understand what happened. Imagine looking up at the sky. A calm morning, blue and silent, birds flying, clouds drifting. Everything feels predictable. And then, a flash. Not lightning, not fireworks. A streak of white fire splitting the atmosphere at 20 kilometers per second. Before anyone can understand what's happening, the shock wave hits. Windows explode, car alarms scream, people fall to the ground as a pressure wave, more powerful than dynamite, slams through an entire city. This is not a movie scene. This happened in 2013 in Chelyabinsk, Russia. And the asteroid that caused it was only the size of a small house. Now imagine something 10 times bigger, or 100 times bigger. Something that has been drifting in space for millions of years, silent, cold, invisible,
Motion
until
connecting
finally
from image
its
64
orbit
to image 60.
intersects ours.
Drift through molten flows.
Asteroids are
natural
not rare.
turbulence.
They are everywhere. Leftover debris from the birth of the solar system. Wandering, unstable, unpredictable. 66 million years ago, one of them ended the age of the dinosaurs. A rock the size of a mountain hit the Earth with the force of 10 billion nuclear bombs. The sky burned, the oceans boiled, the forests turned to ash. Life almost ended, completely. And here's the truth people don't like to think about. The dinosaurs didn't die out because Earth was unlucky. They died out because Earth exists in a cosmic shooting gallery. A place where rocks, ice, metal, and debris constantly cross our orbit. And that will never stop. Today, Hollywood teaches us to fear giant planet killers. But scientists fear something else much more. The small ones. The ones too dim to detect. The ones that sneak up on us from the blind spots of telescopes, from the glare of the sun, or from below Earth's orbital plane where we never look. Chelyabinsk, 2013. Thousands injured. No one saw it coming. Now imagine a Chelyabinsk-sized object exploding over New York, or Beijing, or London. Skyscrapers would shatter. Glass would turn into knives. Millions could be injured in seconds. And that's just an asteroid 20 meters away. Earth is surrounded by tens of thousands of near-Earth objects, NEOs, whose orbits cross ours. We track the big ones. We catalog the predictable ones. But the small ones slip through the darkness like cosmic ghosts. The good news is that humanity is not defenseless. In 2022, NASA launched one of the boldest experiments in space history. DART, a small spacecraft, no larger than a refrigerator, crashed into a distant asteroid moonlet named Dimorphos, and it changed its orbit, proving without question that we can push an asteroid. We can deflect one. We can alter the path of a cosmic threat. But here's the uncomfortable question nobody can answer. Will we detect the next dangerous asteroid early enough to stop it? Because deflection is not the hard part. Detection is. If we find a dangerous object 20 years before impact, we win. If we find it 5 years before impact, we have a chance. If we find it 6 months before impact, we have no options. If we find it on the day it arrives, there is nothing left to do but pray. Astronomers call these objects city killers. not because they destroy planets, but because they are perfectly sized to wipe out one city instantly. A modern metropolis erased in a single flash. Imagine a 100-meter asteroid detonating over Tokyo. The shock wave would flatten buildings for kilometers. The heat would ignite everything flammable. Infrastructure would collapse. Hospitals would be overwhelmed. The global economy would tremble. Not the end of the world, but the end of the world for millions. And the worst part, most asteroids in this category are still undiscovered. Some approach from the sun's direction, completely invisible to ground telescopes. Some have dark, carbon-rich surfaces, so black they reflect almost no light. Some move in orbits we simply haven't mapped yet. Space is big, our detection systems are small, and the universe does not warn twice. But the story is not all fear. There is hope. New infrared telescopes are being developed. Space-based observatories are on their way. Next-generation surveys will scan the sky every 30 seconds. And international defense systems are being designed that could one day protect the entire planet. But we are not there yet. Not fully. Not safely. Right now, the truth is simple. The next asteroid that hits Earth is already on its path. It is already moving, already drifting, already falling through space along an orbit controlled by nothing but gravity and time. The only question is, will we see it? Or will it arrive the same way Chelyabinsk did? In a flash of light, a roar of thunder, and a shockwave that catches the entire world by surprise. Until our detection systems are perfect, the asteroid threat remains one of the only cosmic disasters that is guaranteed to happen again. The timing is unknown, but the event is inevitable. And if it happens in your lifetime, the world will remember the day the sky exploded. There is an invisible shield surrounding our planet. You can't see it, you can't touch it, but without it, life on Earth would not exist. This shield, our magnetic field, is the only reason the sun hasn't stripped our atmosphere away. It bends solar radiation, deflects cosmic particles, and acts as a silent guardian, protecting every living thing. But what if this shield started to break? What if north became south, and south became north, and the entire magnetic structure of Earth turned itself inside out? This is not a theory. It is a geological fact. It has happened many times before, and one day it will happen again. Earth's magnetic poles have flipped dozens of times across history, sometimes slowly, sometimes in bursts, but always with massive consequences for the environment above the atmosphere.
116, drift to star GRB
Most
candidate.
people hear pole shift and imagine continents sliding across the ocean, radical climate chaos, cities falling into the sea. But that's not what happens. The real threat is far more subtle and far more dangerous for a technological civilization. During a geomagnetic reversal, the magnetic field weakens, not suddenly, but gradually, over hundreds or thousands of years. And when the shield weakens, radiation gets in. High-energy particles from the sun begin reaching deeper into the atmosphere. Auroras spread across latitudes that have never seen them. Cosmic rays intensify. Airplanes, power grids, satellites all become more vulnerable. And here's the unnerving part. Earth's magnetic field is already weakening. Right now, as you watch this video, there is a massive growing region of magnetic instability called the South Atlantic Anomaly, a strange pocket where the field is so weak that satellites glitch when they pass over it. Some spacecraft shut down sensors entirely to avoid damage. Others accumulate radiation doses far higher than expected. It is a sign, a warning, a reminder that Earth's magnetic core is not a static machine, but a churning, molten engine of iron and nickel, constantly shifting. Imagine the magnetic field like a lighthouse beam, steady, bright, protective. Now imagine that beam beginning to flicker, dim, and split into multiple chaotic directions. This is what happens during a pole reversal. For humans on the ground, life might appear normal. You wake up, drink coffee, drive to work. Nothing seems wrong. But above the sky, the story changes. Satellites degrade faster. GPS becomes unreliable. Astronauts face extreme radiation. High-altitude flights absorb higher doses. Electrical grids experience mysterious interruptions. Our modern world depends on the assumption that Earth's magnetic field is stable. But the geological record says the opposite. It changes. It wanders. It flips. And the flip doesn't happen cleanly. It is not a smooth rotation. The magnetic field breaks into fragments, multiple north poles and south poles appearing in strange places. The field twists like a broken compass, and Earth becomes temporarily exposed. Not naked, but vulnerable. This vulnerability is what terrifies scientists and engineers, because we are not a Stone Age species anymore. We are a species wrapped in satellites, sensors, digital infrastructure, and global power grids. The magnetic field is not a nice to have. It is the backbone of civilization. Imagine a world where solar storms become more damaging, not because the storms grow stronger, but because our shield grows weaker. Imagine a world where airplanes must reroute around radiation belts, where satellites degrade twice as fast, where astronauts require new kinds of shielding just to enter orbit. And imagine a world where, during the most unstable phase of the reversal, the Sun fires a major CME straight at Earth. A solar superstorm hitting a weakened magnetic field would be like a hammer striking cracked glass. The damage could cascade through every layer of our infrastructure. And here's something most people don't know. Pole reversals do not occur on a schedule. They do not follow a predictable pattern. The last one happened 780,000 years ago, but the field attempted a partial flip just 42,000 years ago. It failed, but it weakened dramatically. During that period, the atmosphere thinned, ozone levels dropped, radiation increased. Ice cores reveal a period of instability that may have influenced climate and even human migration. Humanity survived, but we didn't have satellites, or grids, or ozone alerts, or anything remotely close to the infrastructure we depend on today. A magnetic reversal is not the end of the world, but it is the kind of event that tests civilizations. Imagine compasses pointing the wrong way, navigation breaking, radiation storms knocking out satellites, airline routes shifting across continents, electromagnetic interference becoming routine, auroras glowing red over Florida, India, Brazil. Beautiful, but dangerous. Some scientists believe the early phase of reversal may already be beginning. Others insist it's too early to tell. But the trend is undeniable. The field is weakening. The anomaly is growing. The poles are drifting faster than ever recorded. North Magnetic Pole has moved more in the last century than in the previous 1,000 years. Something is happening deep beneath our feet. Something slow, something powerful, something inevitable. And when the reversal comes fully, whether in 300 years or 3,000 years, Earth's magnetic shield will be pushed to its limit. Our survival won't depend on luck, it will depend on preparation, on building spacecraft that can handle radiation, on creating backup navigation systems, on hardening satellites, on learning to live in a world where the sky is no longer a perfect shield. Humanity will adapt. We always do. But the transition will not be gentle. Because when the poles begin to flip, the sun will not wait. The universe will not pause. And the shield we trust most, the invisible barrier that has protected life for billions of years, will tremble. The only question is whether we will be ready when it does.
High above the Milky Way, beyond the stars you can see with your eyes, beyond even the reach of most telescopes, there are explosions so powerful that, for a few seconds, they outshine entire galaxies. These are gamma-ray bursts, the most violent events the universe has ever created. Beams of radiation sharper than lasers, faster than thought, and bright enough to burn through light years of space. If one of these beams ever pointed directly at Earth, we would never see it coming. We would never hear it. We would never feel the heat. But our atmosphere would begin to disintegrate, and life on Earth would change forever. But before we get to gamma-ray bursts, let's start with something you've heard of, a supernova. When a massive star dies, it collapses under its own weight. The core implodes, the outer layers rebound, and the explosion releases more energy in a single moment than our sun will emit in its entire lifetime. It is nature's final act of violence. Most supernovae happen far, far away, millions or billions of light years distant. But a nearby one, just a few dozen light years from Earth, could rewrite the future of our planet. Not by blowing us apart. That only happens if the star is extremely close, but by altering the one layer of protection we depend on every day, the ozone layer. Supernova radiation can tear apart oxygen molecules, leaving Earth vulnerable to ultraviolet light. More UV reaching the surface means damaged DNA, collapsing marine ecosystems, and long-term environmental stress. This is not speculation. There are hints in the Earth's geological record that a supernova may have affected our planet in the past, possibly contributing to ancient extinctions. But supernovae are only half the story. The other half is far more terrifying. A gamma-ray burst, GRB, occurs when the core of a collapsing star forms a black hole and fires two narrow jets of radiation at nearly the speed of light. These jets can travel across the universe, slicing through anything in their path. If one of these beams ever pointed directly at Earth, even briefly, just a few seconds, the atmosphere would absorb a massive dose of high-energy radiation. Nitrogen and oxygen molecules would be ripped apart. Ozone would collapse. Ultraviolet radiation would surge. Food chains would destabilize. Surface life would undergo centuries of environmental stress. Humanity wouldn't be wiped out instantly. This isn't an extinction from impact scenario. It's a slow suffocation of the biosphere. A pressure on life so severe that civilization would struggle to survive. And here is the part most people don't know. We don't need a GRBG aimed perfectly at Earth. A slightly off-axis beam could still affect the atmosphere. A nearby supernova could still shock the ecosystem. The threat doesn't require perfection, just proximity. So, is there a star near Earth capable of exploding? The answer is yes, several. But one of them has become almost a celebrity: Betelgeuse. The red supergiant in Orion's shoulder, so massive it could swallow our entire solar system out to Jupiter. So old it is already trembling in its final evolutionary stages. One day, Betelgeuse will go supernova. It could happen tomorrow, or in 100,000 years. Astronomically speaking, that's basically any moment. When it explodes, the night sky will shine brighter than the moon.
Shadows will form at midnight. For weeks, Earth will witness a new star blazing like a cosmic lighthouse. The good news? Betelgeuse is far enough away that the explosion won't harm us physically. The bad news, it reminds us how fragile we are, how tiny Earth is compared to cosmic forces that operate without mercy or warning. But what about gamma-ray bursts? Is there any star near us that could fire one directly at Earth? Astronomers have identified candidates, massive, rapidly rotating stars that could produce long-duration GRBs when they collapse. Fortunately, the most dangerous ones are not pointed at us. Their axes do not align with Earth. The risk is not zero, but it is small. Still, in a universe with 2 trillion galaxies, gamma-ray bursts occur regularly. The only reason we're here to talk about them is pure cosmic luck. And luck is not a strategy. Here is the part scientists struggle to communicate. The danger is not that a star will explode tomorrow. The danger is that humans assume the sky is safe, that high above the Milky Way. Beyond the stars you can see
Ocean
with your
connecting
eyes.
from image 64
Beyond
to image
even
60.
the reach of most
Drift through
telescopes,
molten flows,
there are
natural
explosions
turbulence.
so powerful that for a few seconds they outshine entire galaxies. These are gamma-ray bursts, the most violent events the universe has ever created. Beams of radiation sharper than lasers, faster than thought, and bright enough to burn through light years of space. If one of these beams ever pointed directly at Earth, we would never see it coming. We would never hear it. We would never feel the heat. But our atmosphere would begin to disintegrate, and life on Earth would change forever. But before we get to gamma-ray bursts, let's start with something you've heard of, a supernova. When a massive star dies, it collapses under its own weight. The core implodes, the outer layers rebound, and the explosion releases more energy in a single moment than our sun will emit in its entire lifetime. It is nature's final act of violence. Most supernovae happen far, far away, millions or billions of light years distant. But a nearby one, just a few dozen light years from Earth, could rewrite the future of our planet. Not by blowing us apart, that only happens if the star is extremely close, but by altering the one layer of protection we depend on every day, the ozone layer. Supernova radiation can tear apart oxygen molecules, leaving Earth vulnerable to ultraviolet light. More UV reaching the surface means damaged DNA, collapsing marine ecosystems, and long-term environmental stress. This is not speculation. There are hints in Earth's geological record that a supernova may have affected our planet in the past,
The
possibly
continuous motion
contributing
from
to
photo
ancient
81 to photo
extinctions.
82, drifting
But
into the
supernovae
GPS
are
glitching
only
network.
half the story. The other half is far more terrifying. A gamma-ray burst, GRB, occurs when the core of a collapsing star forms a black hole and fires 2 narrow jets of radiation at nearly the speed of light. These jets can travel across the universe, slicing through anything in their path. If one of these beams ever pointed directly at Earth, even briefly, just a few seconds, the atmosphere would absorb a massive dose of high-energy radiation. Most disasters come from the sky. Radiation, asteroids, solar storms. But some of the deadliest threats to humanity start deep beneath our feet. Quiet, hidden, building pressure for tens of thousands of years. These are supervolcanoes, monsters that sleep for ages, then awaken in a single violent moment. And when they do, they reshape the entire world. The term supervolcano
doesn't just mean big eruption. It means an eruption powerful enough to darken skies across continents, collapse global temperatures, and plunge Earth into an artificial winter that can last years. A normal volcano can affect a region. A supervolcano can affect the planet. The most famous one sits under the United States, Yellowstone. Right now, beneath the forests and geysers, there is a chamber of molten rock so large it could fill the Grand Canyon several times over. But Yellowstone is not the only one. There is Taupo in New Zealand, Toba in Indonesia, Aira in Japan, and many others hidden beneath oceans and deserts. These systems erupt rarely, every 50,000 to 200,000 years on average. But when they do, the planet feels it. Imagine waking up to a sky that is suddenly dimmer, not from clouds, not from nightfall, but from ash. Billions of tons of microscopic dust spread across the atmosphere like a veil. Sunlight weakens, temperatures drop, plants slow down, growing seasons shrink. The world doesn't freeze instantly, it fades, quietly, like a dimmer switch being turned down. This is called a volcanic winter, and humanity has lived through smaller versions of it. In the year 1816, after the eruption of Mount Tambora, the world experienced the year without a summer. Snow fell in June, crops failed, prices skyrocketed, people starved. And Tambora was tiny compared to a supervolcano. A true supereruption would inject so much sulfur into the atmosphere that the sky would turn a pale milky white. Sunsets would glow red. Temperatures worldwide could drop by several degrees. Monsoons could collapse. Harvests could fail year after year. This is not a fire and lava apocalypse. It is a slow, grinding catastrophe, the kind that creeps into every aspect of human life: food, energy, economy, stability. Civilizations don't fall because of lava. They fall because they run out of food. But what makes supervolcanoes especially terrifying isn't just their power. It's the fact that we don't fully understand what triggers them. Pressure builds, gas accumulates, cracks shift, the magma chamber stirs, and sometimes external forces play a role. Climate change, glacial melting, even impacts from space can alter the weight on Earth's crust. Yes, a cosmic event can trigger a geologic one. When the dinosaur killer asteroid hit Earth,
The
it
motion
didn't just
connects
set
from image
forests on
115
fire
to
or
image
create
116.
tsunamis.
Drift to
It may
star
have
GRB
destabilized
candidate.
volcanic systems around the world. Cosmic violence, awakening Earth's inner fire. Earth is a system, and everything is connected in ways we barely understand. So what would a modern supereruption actually look like? First, earthquakes. Not huge ones, but many, swarming, a sign that magma is rising. Then, gas emissions increase. Ground lifts slightly. Geothermal areas shift. Animals behave strangely. Scientists would detect it, yes, but stopping it? Impossible. When the eruption begins, it doesn't explode upward like a narrow column. It erupts sideways, like a pressure cooker, exploding from every seam. Ash clouds erupt at hundreds of meters per second. Pyroclastic flows sweep across the land. Lightning crackles through ash so dense that the sky turns black at noon. Airports shut down. Solar panels dim. Power lines fail from the weight of ash. Water supplies clog. Roofs collapse. Agriculture halts. And then comes the global effect. Within weeks, aerosol particles spread around the hemisphere. The planet cools. Rainfall patterns shift. Crops in multiple countries fail simultaneously. This is one of the few disasters on this list that humanity has zero defense against. We cannot deflect it. We cannot shield ourselves. We cannot engineer the pressure away. All we can do is adapt. And here is the deeper truth most people never consider. If a supervolcano erupted during a period of fragile global stability, economic strain,
food insecurity, political tension. The eruption itself wouldn't be the catastrophe. The chain reaction would be migration, resource competition, conflict, market collapse, panic, governments destabilizing. Human behavior during crisis is often more dangerous than the crisis itself. Yet, despite all this, supervolcanoes remain one of the least discussed threats on Earth, not because they're unlikely, but because their timelines are slow. Centuries, millennia. Humans don't fear what moves slowly, even if it's inevitable. But the geologic clock doesn't care about human attention spans. It ticks with or without us. And one day, somewhere, one of Earth's supervolcanoes will take its turn. Not because the planet is angry, not because we did something wrong, but because Earth is alive, restless, shifting heat from its core. And when that heartbeat surges, the world must learn to endure the cold that follows.
When you look up at the night sky, you see stars, planets, the quiet emptiness of space. But if you could remove the darkness, if you could see every object orbiting Earth, the sky would not look empty at all. It would look crowded, chaotic, like a swarm of metal insects circling the planet at 28,000 kilometers per hour, because Earth is surrounded by junk. Broken satellites, fragments of old rockets, shards of aluminum, steel, paint, some no larger than a grain of sand. But at orbital speeds, even a grain of sand hits with the force of a bullet. Space is becoming a minefield, and one day, that minefield could collapse in on itself. This is the nightmare known as the Kessler Syndrome, a chain reaction of collisions that could trap humanity on Earth for decades. To understand the danger, you must first understand how fragile orbit really is. Every satellite we rely on, GPS, weather tracking, communications, banking, climate monitoring, floats in a thin shell of space just a few hundred kilometers above Earth. This region, called low Earth orbit, is not infinite. It's a narrow ring, a cosmic highway, and it is filling up. Every time two objects collide, they don't create one piece of debris, they create thousands. Each shard becomes a new projectile, a new threat, a new chance for another collision. This is the Kessler Cascade. One impact leads to 10, 10 lead to 1,000, and the chain reaction spreads like a virus. In the worst-case scenario, orbit becomes so dangerous that no spacecraft can pass through it safely. Humanity would lose access to space, not because we ran out of rockets, but because we polluted the sky with our own machines. Imagine a world with no GPS, no satellite weather forecasts, no international communications networks, no global financial timing systems, no reconnaissance satellites, no space exploration, no way to launch astronauts or probes. A technological blackout, not caused by radiation, not by a solar storm, but by our own debris. This is not hypothetical. We have already had warning shots. In 2007, a Chinese anti-satellite missile test destroyed a satellite and created more than 3,000 pieces of trackable debris. In 2009, two satellites, Iridium-33 and Cosmos 2251, collided by accident. The event sprayed orbit with thousands of fragments still circling the planet today. Right now, as you listen to this, Earth is orbited by over 30,000 tracked objects and more than 1 million pieces too small to track, but large enough to destroy a spacecraft. Every one of them is moving faster than a rifle bullet. A screw, a chip of paint, a sliver of metal. Any of these could tear through a satellite like a knife through paper. And because there are so many satellites now, Starlink, OneWeb, thousands more coming, the probability of collision is rising every year. We are building the future of communication, but also the future of a cosmic traffic jam. So how exactly does a Kessler Cascade start? Not with something traumatic, not with an explosion. It starts with a single collision. One satellite hits a discarded rocket stage or a stray bolt drifting through space.
The impact creates a cloud of debris. That cloud hits other objects. Those collisions create more clouds, and each cloud spreads into new orbits, multiplying outwards in every direction. Within hours, orbit could become a shooting gallery. Within days, entire orbital lanes could become unusable. Within weeks, launching a new satellite might become impossible. Space agencies would be blind, global communications would stagger, weather monitoring would fail, navigation for ships and aircraft would degrade. Modern civilization depends on the sky more than anyone realizes, and Kessler syndrome threatens to turn that sky into a weapon aimed at ourselves. But humanity is not standing still. Scientists and engineers had begun designing a new class of spacecraft, space janitors. Satellites that use nets, harpoons, magnetic tethers, drag sails, ion beams. Some will grab debris, others will slow it down so it falls into the atmosphere and burns up. New rules are being written. Every satellite must be removed from orbit within 5 years of its mission ending. Companies are required to plan a safe deorbit path before they even launch. Space agencies now simulate traffic in orbit, the same way cities track airplanes and ships. And for the first time in history, the world is taking orbital pollution seriously. But is it enough? No one knows. Because once a cascade begins, there is no way to stop it. We can only prevent it, and prevention is a race against time. Every new launch increases the risk. Every new satellite becomes a potential projectile. And every year, the sky grows a little more crowded. Orbit is not a junkyard where we can keep piling trash. It is the bloodstream of civilization. And if the bloodstream clogs, the body fails. The Kessler syndrome is not science fiction. It is a warning, a reminder that humanity's future in space depends on our ability to keep orbit clean. Because if we fail, the stars will not be waiting for us. They will be locked behind a wall of our own making, a prison of metal, circling overhead forever, out of reach. And the greatest irony is this. After thousands of years looking up and dreaming of the sky, the thing that ends our access to space might not be nature, but ourselves.
For billions of years, Earth has been a sanctuary. A rare island of warmth and liquid water in a cold, indifferent universe. A fragile bubble of life orbiting a star that has given us everything: light, heat, energy, and time. But stars do not last forever, and neither does life. Because deep inside the sun, a clock has been ticking since the day it was born. Not a countdown to an explosion, but a slow transformation, a gradual brightening, a continuous, unstoppable rise in heat. The sun is getting hotter, right now, every second, every year, every century. It's a tiny increase,
systems are go.
far too small to feel in a single lifetime. But over hundreds of millions of years, it adds up. One day, the slow warming will push Earth past a threshold. Not suddenly, not violently, but inevitably. Earth will enter its long death. To understand this, you must imagine the sun not as a static object, but as a nuclear furnace growing more intense with age. As hydrogen in the core is consumed, the sun compensates by burning hotter, brighter, stronger. And Earth, sitting in the so-called habitable zone, moves inch by inch toward the inner edge, toward conditions that life cannot survive. The first stage of Earth's death will not look dramatic. Temperatures will rise a few degrees. Oceans will evaporate slightly faster. Humidity will climb. Weather patterns will shift. Deserts will expand. Humanity might adapt for a while, but the process continues. More heat, more evaporation, more water vapor, which is itself a greenhouse gas. A feedback loop begins. Clouds trap heat, oceans shrink, rainfall patterns collapse, ice disappears completely. Earth does not turn into fire, it turns into a sauna.
a steaming, suffocating world trapped under its own atmosphere. This stage is called a moist greenhouse, and once it begins, there is no way back. The oceans will boil, not violently, just relentlessly, steadily, day after day, year after year. As more water escapes into the upper atmosphere, UV radiation from the sun will break it apart. Hydrogen will drift into space permanently. Every lost molecule is one drop of ocean that can never be replaced. Earth will dry. Eventually, the planet will be stripped of water entirely. A barren desert, a world of cracked continents and silent basins where oceans once lay. Earth, the blue dot, will become Earth, the pale dot, a replica of Venus, but colder, older, and lonelier. Life will not disappear in a single moment. It will fade with the oceans.
Connecting from image
The last
64 to
survivors
image
will
60.
live underground,
Drift
or in
through
deep
molten
caves,
flows,
or near the
natural
last pockets of
turbulence.
water clinging to shaded craters at the poles. But even they will eventually lose the battle. Because as Earth dries, the sun continues to brighten, and in roughly 1 billion years, Earth's surface will become uninhabitable to all known life. Not because of an asteroid, not because of a gamma-ray burst, not because of a supervolcano, but because the star that nurtured us slowly becomes too powerful for us to endure. This is the destiny of all habitable planets. Warmth becomes heat, heat becomes fire, fire becomes death. But Earth's story doesn't end there. It gets worse and more dramatic. In about 5 billion years, the sun will exhaust its hydrogen entirely. The core will collapse, the outer layers will swell, and the sun will transform into a red giant, a star so large it could swallow Mercury, then Venus, and perhaps even Earth itself. Even if Earth escapes being consumed, the heat will vaporize the crust, mountains will melt, oceans will be long gone, the atmosphere will be blown away. Earth will become a glowing ember in a star's dying breath. Everything that ever lived, every tree, every ocean, every organism, every memory will be erased. The quiet blue dot will vanish from the universe. But here is the truth that matters most today. This is not happening tomorrow. This is not happening in 1,000 years, or 10,000, or 1,000,000. The slow death of Earth is far beyond any human lifespan, far beyond any civilization, far beyond the lifetime of our species. So why does it matter? Because it reminds us of a fundamental truth. Earth is not a permanent home. It never was, it never will be. Every species that survives long enough must eventually leave
The
its
continuous
birthplace.
motion from photo
We are
81
no
to
different.
photo 82.
If humanity
Drifting into the
stays on
GPS
Earth forever,
glitching network.
our fate is sealed. Not by war, not by climate change, not by cosmic impact, but by astrophysics. To survive, we must become a multiplanetary species, then a multistellar species, and eventually a species that can build habitats independent of stars entirely. The future of life is not tied to Earth. It is tied to our ability to grow beyond it. The slow death of Earth is not a tragedy. It is a deadline, a cosmic reminder that survival belongs to those who move forward. The dinosaurs never had that chance. We do. And the question now is simple. Will humanity rise to meet the timeline of the stars? Or will we remain on Earth until the sun turns the sky white and the oceans into steam? The universe is vast. The possibilities are endless, but the clock is ticking. Earth gave us life. One day, we must choose to leave it to save everything life has created. That choice will define our place in the cosmos. We have just traveled through 7 disasters, 7 ways the universe can shape, disrupt, or even erase life on Earth. Some of these threats are distant, some are slow, some are rare, and some
like solar storms, asteroids, and orbital debris, are close enough that they could unfold within our own lifetimes. But there is one truth that connects all of them. The universe is not hostile. It is indifferent. It does not hate us. It does not protect us. It simply moves according to the laws of physics that existed long before humans ever opened their eyes. And yet, despite facing a cosmos filled with radiation, collapsing stars, rogue rocks, magnetic chaos, volcanic fury, and the slow death of our planet, humanity is still here. Fragile, temporary, but here. That alone is extraordinary. Because every sunrise you see is a cosmic miracle. Every quiet night is a moment of peace bought by billions of years of chance. Every heartbeat is an act of defiance against the cold vacuum that surrounds our world. But here's the real reason these 7 disasters matter. Understanding them is how we survive them. Civilizations don't fall because the universe is dangerous. They fall because they refuse to look up. They fall because they assume tomorrow will always look like today. But the future belongs to the species that prepares, the species that learns, adapts, builds, explores. And that is why you are here. Not for fear, but for awareness, curiosity, perspective. By learning how the universe can threaten us, you also learn how humanity can defend itself. We can watch the sun. We can track asteroids. We can shield satellites. We can build planetary defenses. We can clean orbit. We can prepare for climate extremes. We can design new worlds beyond Earth. Because the universe does not care if we survive. But we do. And that is enough. Now I want to hear from you. Out of these 7 cosmic threats, which one feels the most real to you? Which one feels closest to our lifetime? Which one should I turn into a full deep dive simulation next? Type a number from 1 to 7 in the comments. Your pick might become an entire episode. And if you've watched all the way to the end of this video, you are officially part of the Astro 365 crew. A community of people who don't just accept the universe as background scenery, but try to understand it, challenge it, and one day
The motion connects
reach
from
beyond
image
it.
115 to image
So,
116.
if you haven't already,
Drift to star
hit subscribe.
GRB candidate.
It takes 1 second, but it unlocks the next 30 episodes in this series. Episodes about deep space, alien oceans, dark energy, interstellar travel, and the technologies humanity is building to protect itself from the very threats you just heard. And here is your teaser for the next video. While the universe can hit Earth with storms, rocks, and radiation, humanity is not defenseless. In the next episode, you will discover how we are quietly building an invisible shield around our planet, a real, functioning, multi-layered defense system that operates from the ground, the sky, and space itself. If you thought today's disasters were terrifying, wait until you see what we can do about them. This is Astro 365. Thank you for watching, and remember, the universe is vast, the dangers are real, but so is our potential to rise above them.